important that you take an opportunity, if you haven't yet, to make sure you understand that material. We talked last time a little bit about array lists, which are lists that have a list interface, but they are implemented as arrays under the hood. So if you look underneath an array list, if you look at what is inside of the array list class in Java, it has an array in it. Now, there are different reasons to use arrays versus other types of data to store lists. They're more efficient at some things, they're less efficient at others. You're going to get into a lot of the details of this when you get to data structures, but that's the basic definition of an array list. One other type of list that's really common that you're going to see a lot of is what we call a linked list. The idea of a linked list is that we have a bunch of pockets of data. And rather than, so an array is just a contiguous block of memory, all together, all in one place. The compiler knows exactly where all the data is, lined up from end to end. So that makes it pretty fast for accessing information. But it makes it hard to grow or shorten the data because you have to move stuff around and you have to keep that memory all in one place. Linked lists are like the opposite of that. Rather than having one big block of memory to store everything in, they have these little pockets of memory, what we call nodes. And a node is a block of memory that we can store value in, and it has two parts to it. It stores value for the data, and then it also has a reference, a pointer to the next block of data. So it's like, I'm here, here's the information I hold, here's the next place to go. So it holds its current value, and it also holds a pointer to the next node. So hopefully that makes sense. So basically we have a bunch of signposts where we have some data and we have a pointer to the next block. And when we get to that other block, we have the data and then we have a pointer to the next block after that, and so on and so forth. So Java has an implementation of a linked list built in. And if we create a linked list, which is a type of list, then the way it starts out is that it has nothing in it. Linked lists have two things that they have to keep track of all the time. They have to keep track of where's the front of the list and where's the end of the list. Makes sense, right? You've got to know where the list starts and where it ends. When you start with an empty list that has nothing in it, both of those, the front and the back, point to null. They say, we have nothing. We're not storing any information. As you add things to that list, so let's say we were making a list of songs, right? You've seen these examples before. I'm going to reuse the song lists. If we have a list of songs we're building, and we go to add another song, so we're going to add the song Barbie Girl to the list, then this is our first node right here. So we have the pointer, the reference to the front, the reference to the back, and then we have the node here, right? So this holds Barbie Girl. So when we only have one thing in our list, it's the front and it's the back at the same time. So that's why both front and back point to this, because it's the only thing in our list. Now, every node, this is a node, every node has the data, in this case the song Barbie Girl, and it has a reference to where to go next. But if there's nothing else in the list, then there's nowhere else to go. So that's still going to point to null. Hold on just a second. Let me add the next one, and then I'll answer any questions. So, if we add another one called Dancing Queen, it's going to look like this. So, the front is Barbie Girl, but now the back of the list is Dancing Queen. From Barbie Girl, the next one is Dancing Queen. From Dancing Queen, there's nothing else. We're at the end of the list. Okay, so that's the basic setup. You had a question?
Yeah, it's from a little bit from before, but do you want us to know like what's under the hood? That's what you called it?
Yeah, do I want you to know what's under the hood for these different data types? Yes. So you should know that an array list under the hood is an array. You should know that for a linked list, it's a sequence of nodes. Yeah, that's important to know. Yes? That's a good question. The question was, so in a linked list, the question was, do we always point to null at the end? And the answer is, we do, because a node always has two things. It always has data, and it has a pointer to the next. If there's nothing else next, that has to be null, so that we know that we're at the end of the list. So it's not like an empty node, it's a pointer to null. So there's a difference between those. Does that make sense? Yes?
If the last thing is null, why do we know what the last actual thing is?
So keep in mind, the back is not the pointing to the null, it's pointing to the last actual element of data. And the reason you need to know where the back is because, well, there's two options, right? So let's assume that we didn't have a pointer to the back, which you could do. Every time you add a node, how are you going to find the last element that's not null? So you're going to have to go through the whole list, which is expensive and inefficient. It takes a lot of CPU time, especially the longer your list gets, the worse it would get. So while technically you don't have to have a pointer to the back, if you don't, it makes it really inefficient. Does that answer your question? Yes? What is a node? A node, strictly speaking, is an element in a graph. That's what it means. So here's an example from airlines. So if you have a location, an airport, in an airline's network, that is actually called a node in the airline's network. So anytime you have some point that connects to other points, that's what a node is. In our case, we have very simple nodes, so we have some data, and then we have an arrow that points somewhere else. So they only connect to one other place. Yes?
Does a linked list have an index or is that?
Good question. The question was, does a linked list have an index? And the answer is not implicitly. So it doesn't have an index all by itself. What you can do with a linked list is that you can count as you move, so you can count up as you travel the linked list, but you can't go directly to a node. And that's one of the drawbacks of a linked list as opposed to an array list. An array list, if you go to an index, you can go directly to that index. There's no cost that's significant, like the memory, you can directly access that memory. With a linked list, you have to start at the beginning or the end, but one of the two. Best case scenario, you find the element the first time you hit it, but in the worst case scenario, you have to go through the whole list to find what you're looking for. Does that answer your question? And this is the trade-off, right? So linked lists are very flexible because you can probably see it's really easy for us to add more stuff to a linked list. It's easy for us to take stuff away from a linked list. That's harder with an array list because, especially if you take off of the front for an array list, then you have to move a whole bunch of stuff around and you have to copy stuff. Whereas with a linked list, you don't have to do that, right? You just pull the element off and that's it. It's pretty inexpensive to grow or shrink a linked list. The drawback is that if you're trying to access elements in a non-sequential manner, if you're trying to have random access to elements, it gets very expensive. So that over-answers your question, but hopefully it hits on what you're asking. Anyone else? Yes?
Can you link array lists?
Can you link array lists? So you could have a linked list of array lists if you wanted to. Or are you asking, could I have like a linked list with pointers to nodes that point to next?
It's more like, can you start from a block of data, like have an actual block of data, and then move to different blocks?
I suppose you could do kind of, you're talking about kind of like a hybrid between the two. Yeah, I think that would be possible, you know. Yeah, I don't see any reason why I wouldn't. I don't know anybody that uses that. Well, you know, I guess some types of trees actually use an approach like that. So it's not unheard of, but it gets very messy very quickly. But you can do it, yes. Okay, did anyone else? I thought I saw a hand, but maybe it was just stretching. All right, anyone else have any questions at this point? So, the key thing with a linked list is that we have to keep track of where the front is and where the back is, and we have to always have a pointer to where we're going next. So right now you don't have to actually implement this stuff because it's implemented by Java. Eventually, in your career here at the University of Florida, or in the industry, you're going to have to build a linked list at some point. So this is kind of like an introduction to the idea. So let's say we wanted to add another song, I Need a Hero, then the same thing would happen. So what's going to happen to this back pointer?
It's going to move so very.
Right, it's going to move to whatever our new element is. And then Dancing Queen is going to point to I Need a Hero, and I Need a Hero's next is going to point to null. Right? And this is how the linked list evolves. If we added another element, then I Need a Hero would point to that new element, and back would point to the new element, and so on and so forth. So we can keep adding stuff. Yes?
So
So the way to think about it, like it has a fixed base, so then you just throw stuff, more and more stuff on top of it.
Yes, so we have two fixed pointers, the front pointer and the back pointer, or references. And we can throw stuff, we can add stuff onto it. We can actually take stuff off of the front or the back of the linked list. That's one of the really powerful things, is that, for example, let's say we wanted to pull stuff off of the front, we could just move the front pointer here, and then we can take this off of the list.
So then you can't do it with like the middle or anything.
You can do it with the middle, but then you have to fix the pointers on both sides. Yeah, which you do have to do sometimes in the linked list. But it's still less complicated than doing it with an array list. It's way worse with an array list. So, yeah, adding and removing from an array list is complicated.
Did you say you could go through like the index though and go straight?
Well, you can go straight to the data element, but removing an element is different, right? The array list itself is not a problem if all you're doing is accessing the data. It's when you need to move stuff around that array lists get really complex. And linked lists are way simpler for moving stuff around. Yes?
What's the difference between a linked list and a deck?
What's the difference between a linked list and a deck? Well, strictly speaking, they're different concepts, right? A deck is an abstract type. It's not something you implement directly. A deck is like an idea in computer science. You have this list that you can push and pull from both sides. A linked list is a specific way. It's actually one of the ways you can implement a deck. So, in fact, if we go, here, let me go back real quick.
So
a
a linked list is a type of deck.
Well, it's more accurate to say that you can implement, you can use a linked list as a deck. That's probably the most accurate way to say it. So, for example, this is an example. No, that's stack, not deck. All right. Here's a deck. So, any day now. So there are one type of deck is a linked list deck. So in this case, we're actually using a linked list as our deck type. So there's a bunch of different types of decks, and you can use a linked list as a deck.
Okay.
Does that make sense?
Yeah, okay, got it. Yes.
All right, so let me get back to where we were. Okay, so let's say that we wanted to go and remove the things from a linked list. We're basically doing the same process in reverse. We pulled it, let's say we pulled the first element off, right? Then we move the front pointer to whatever our next element is. And we pull the data off. In this case, we're printing the information. Then if we pull off Dancing Queen, the front pointer is going to move here, and we'll print Dancing Queen. If we remove the last element, now front and back point to null again. So with a linked list, we can pull from either end, which makes it a lot more flexible than an array list, where pulling from the front is an extremely expensive operation. Yes?
So is this first in, first out?
So one nice thing about a linked list is it can work, the way I've set it up here is first in, first out. But the nice thing about a linked list is you can use it in either form. Yeah. But queues are most often, if you have a straight FIFO queue, first in, first out, not a priority queue, but just a straight FIFO queue, a linked list is a really common way that those are implemented. Yes?
How come something's printing there?
What's that?
You're calling .remove. Why is it printing something?
So the question is, why is it printing something when I call .remove? The answer is, this is not universal, but in Java, when you remove an element from a list, using remove, it returns that element to you. So in this case, .remove is removing the element and returning it, and then we're printing what gets returned. Okay, yes?
On line 14, since you don't have an argument for a song.remove, does that mean it removes the first one?
Good question. The question is, since I don't have an argument for the remove here, since it's just the two parentheses, does that mean it removes the first one? And the answer is yes. That's what remove with no parameter does, is it removes the first element. Yes? What would I have to do to make it go in reverse order? So there's two things you can do. You could go to the size -1, but I believe, I'll have to double check this, I believe linked list has a pop function, which would pull from the back. I'd have to double check it, but that, it is all in the API. There's definitely a way to grab that last element. Did you have a question?
Yeah, so .peek varies through the linked list?
So, good question. The question is, what does .peek do? .peek lets us see the first element without actually taking it off of the list. So this is saying while the front of the list is not null, that's basically what this is checking for. Yes.
With that while function, wouldn't you need like have a variable keeping track of what element you're looking at, or?
That's a good question. The question was, wouldn't we need a variable to keep track of what we're looking at? And the answer to this one is, we actually don't, but only because the linked list itself is changing every time. Because we're pulling an element off of the front every time we loop, the list gets shorter over time. Does that answer your question?
But if we use like peek without removing, then we have.
Right. If you use peek without remove, then if you didn't want to destroy the list as you went, then yes, you would have to keep track of where you were. And that's what we have iterators for, which we talked about 2 weeks ago, I think? Yeah, something like that. Okay, yes?
So dot removes it and prints it?
Dot remove removes it and returns it. In this case, because we're calling print on whatever gets returned from remove. Does that answer your question? Okay. Yes?
Would that list be kind of like enumeration, where you have like the values and then like the numbers you just need to assign automatically?
You could consider this similar to enumeration in this case, yes, because it's like, you don't need to know what the ordering is of the list. I mean, you could, but it's not necessary to use a list to actually know the ordering numbers or the indices. You can just use the list and say, add stuff to the list and take stuff off of the list.
And then like, but since it returns like the actual string value.
Well, yeah, it's returning whatever we put into the list, that's what it's returning. Because we added strings to the list, that's what gets returned to us. If we had put something else in the list, like integers, then it would return integers to us. Yes?
So the songs are no longer in the list after dot remove.
Right, so after this function executes dot remove, those elements get pulled out of the list, and they get returned to us so we can do what we want with them. But yeah, they get removed from the list. All right, I think we're good. Oh, yeah, we got one more, okay.
So the opposite method for remove should be add.
The opposite method for remove is add, but add adds it to the end, not to the front.
Right.
Yeah,
You also use push and pop to add.
you can use push and pop, but be careful about mixing the metaphors, only because they push and pull from different ends of the list. Okay, so that is a linked list. Oh, by the way, all that happened on the heap, I guess my ordering of the animations was wrong. Yeah, I'll fix that next time. Okay, so what I want to do now is I want to revisit some stuff that we started talking about when we were talking about classes. So, and then we'll take a break, because I'm sure that you guys are looking for a break. So let me see here, actually, I gotta get to the right slide. So we've covered a lot of stuff about the basics of slides. We talked about that last week. We talked about overloading methods. We talked about this and the object class. What I want to talk to you now is about some more advanced techniques we can use with classes. And the first one is what we call nested classes, also known as classes inside of classes. Turtles all the way down, right? Yes, class inception. So basically, the idea of nested classes is that we can nest, we can put another class inside of a class. So if we're going back to our, monster battle paradigm that we've been using for so much stuff lately, maybe inside of the monster class, we might want to have an inner or nested class called, in this case, it's called attack. So I have this class called attack, and attack represents an attack that a monster can do. It's going to have a name and a type of damage, just like any other type of class. We're going to have constructors and methods and all that other stuff in them. The only difference is that this class is it's considered a part of the other class. It's really more than anything else an organizational technique. So the main function of this is to allow us to organize things in a way that makes sense to us. Strictly speaking, this does not have to be inside of this other class. We could have it outside, but we're using it for organizational purposes. So, let's say that we wanted to, and I'm just going to put, the animations are just totally out of order here. But let's say that we had this class, this function myProgram, this program, myProgram, and we could say, well, I want to create a new monster attack. If I want to do that, because this is a class that's inside of another class, would be monster.attack is the type. So the type for this new object I'm going to create is monster.attack. Because it's the attack class inside of the monster class. Does that make sense to everybody? Okay. So when I go to create it, I'll call the constructor just like I would for anything else. It's monster.attack crush, comma 10 in this case, which means the damage is going to be 10, and the attack name is crush. Yes?
Since we're using objects, what does it mean for the attack class to be static?
Well, oh, that's a good question. We're going to jump into this in just a minute and in more detail. But the question was, what does it mean for the attack class to be static? And what that means is that the attack class is not linked to any object of the monster class. If that just sounds like gibberish at the moment, it's going to make a lot more sense in a minute. But that's the basic idea, is that just like anything else that's static, it means it is not bound to a particular instance, a particular object of the monster class. Yes?
For line 5, how does it know you're calling it crush, but how does it know it's the name?
Well, this is the type right here. This is the data type. Monster.attack is the data type. Crush is the name. It's like the variable name, right? So it's just like if I had int Bob. This would be int, and this would be Bob. So it's just the data type is monster.attack. The variable name is crush.
Okay.
Does that make sense?
Mm-hmm.
Yes.
Well, if you want to like print out all the information about your monster, including like attacks, how would you like get everything to pop up?
Oh, so how would I get everything to pop up if I wanted to print off the information? I would probably have methods in here that printed stuff. So I don't have that right now because I don't have enough space, to be perfectly honest. But I could add methods to get that stuff or to print it out. Okay, so that is the basic idea here, is that we have this class that's inside of another class. So right here, I've also added a data element. This has no name. It should be called attack. Can you tell I'm still like creating the slides right before I show up? What's that? I mean, I just edited it just now. So. Oh, did I created the slides right before I came to lecture. That was the question, yes. Okay, so yeah, so this is the variable attack, and it's of type attack. So right here, I've created this variable that's a part of the monster class called attack, and that's going to hold on to whatever the monster's proper attack is, right? It's going to hold the variable that points to that object. So basically what we're doing here is we have a monster object, just like our previous constructors. It takes in a name and a level. We have a function that will return the attack object, if we call it with getAttack, and we have another function that will let us set the attack for a particular object. So we create this new attack called Crush, and then we create a monster called Pika, right? And then we set Pika's attack to be Crush. Right? That's what this is doing so far. Then we want to get the name of that attack. So we do the variable name for our monster is chew. So we do chew.getAttack. That'll get the attack object. .getName. That'll call the getName. Oh,
Remember, slides are out of order.
yeah. The slides aren't out of order. I just have no motor skills. That's the problem. So we called the getName function here, which will return the name of the monster. The name of the attack, and that's going to be the attack that we got from chew, which is the one we created up here. So when we get that string, we print it out. It's going to print new attack, and the attack is crush in this case. Okay, so does anybody have any questions about these nested classes? Yes.
So for a string attack, you can actually put a get after a get.
Yes. So the question is, I'm going to generalize your question. Can you put a method after a method? And the answer is yes. The way you have to think about it is, this first method called chew.getAttack, that's going to return a reference to an object, right? And then we're calling the method of that reference, of that object, we're calling the getName function from that.
It's kind of like you're taking apart it. Like the first one,
Yeah.
saying you're finding the actual attack, then you're breaking the attack elements apart and just grabbing it.
Right, so the first part is getting the attack, the second part is getting the name of that attack. Yes?
Would it also work for line 11? Would it work if you do monster.true.getAttack.getName?
So, so your question is right here on line 11, would
Just put monster.true.getAttack.getName.
would monster.chew work? In that case, it wouldn't because chew is the variable name. Monster is a type.
Okay.
Okay? All right, anyone else? Yes.
What do you have empty parentheses there? What could only give you one attack?
Right here?
Yeah.
Yeah, so, well, this is, remember, we set the attack object, and then our getAttack function returns the object that we set before. So that's why the reason it's empty parentheses is because we're just saying, hey, chew, Pika, give me your attack. Give me the attack object that you use. Does that make sense? Anyone else? Yes.
Just what is the get name doing? What is the method?
Right, so in this case I've kind of shortened some of this stuff because for as a matter of space, I put like the ellipses. In this case, getName is just returning the string name inside of the object. So, does that answer your question? Okay, so that is the idea of nested classes. I feel like people need to take a break. Is that true? Okay, let's take a break. Please be back.